Welcome back to Madam YY channel. Today I'm going to discuss the stability of the free radical and carbon cation formed from the cleavage reaction. As we know, free radicals are formed from the homolytic cleavage reaction. So here is the arrangement of free radicals in the order of increasing stabilities. So methyl carbon free radical is the least stable, and we have the primary carbon free radical, which is more stable than methyl free radical, followed by secondary carbon free radical, and the tertiary carbon free radical is a more stable free radical. So this is primary free radical because it's attached to one alkyl group, and this is secondary free radical because it's attached to two alkyl group, and tertiary carbon free radical because it's attached to three alkyl group. So based on the arrangement, we can say when the alkyl substitution increase, the carbon radical will be more stable. So when we say when the alkyl substitution increase, the free radical will be more stable. So how does the alkyl substitution affect the stability? So as we know, carbon free radical only have one electron, so it is electron deficient. It has an unfilled 2p orbitals. So when it is electron deficient, so it can be stabilized by substituents such as alkyl group. So alkyl group includes CH3, CH2, CH3, CH3, CH2, CH2, and so on. So we say alkyl group is an electron releasing group. So electron releasing group, it will give more electrons to the free radical carbon. So the conclusion will be when the number of alkyl increase, the stability of free radical will increase. Next, we will look at how is the formation of carbocation and carbanion from the heterolytic cleavage reaction. So C is bonded to a Z atom. So carbon is more electropositive and Z is more electronegative. So when the single bond break, both the electron will be transferred to the more electronegative Z atom, causing our carbon to become electron deficient. So it will become a positive carbon ion, and we have a negative Z ion. So the positive carbon ion is known as carbocation. And when C is more electronegative than the Z atom, so when the single bond break, both electrons are given to the carbon atom. So the carbon atoms will become a negative ion, which is known as carbanion, and we have the Z cation. So you have learned the formation of carbocation. So now let's compare the stabilities of carbocation. So this is a methyl carbocation because the carbon does not attach to any alkyl group. And this is a primary carbon cation because it's attached to one alkyl group. And we have the secondary carbocation and tertiary carbocation because it's attached to three alkyl groups. So we can see the stability of carbocation increase from methyl to primary carbon cation to secondary carbon cation, and tertiary carbocation has the highest stability. So we can say when the alkyl group substitution increase, the carbocation stability will also increase. So as we know, carbocation is electron deficient, so means that the carbon ion is lack of electron. So it has an empty 2p orbital. So it can be stabilized by substituents such as the alkyl groups. So alkyl groups is an electron releasing group. So we say number of alkyl group increase, the stability of carbocation will increase. Now we will compare the stability of carbanion. So this is a tertiary carbanion, which is the least stable, and we have secondary carbanion, which is more stable, followed by primary carbanion, and the methyl carbanion is the most stable. So this is opposite with the carbocation. So carbocation, we have the tertiary carbocation, which is the more stable. However, tertiary carbanion is the least stable. So we can say the increase the alkyl substitution, the decrease the carbanion stability. So the increase the alkyl group, that decrease the stability of carbanion. So based on carbanion, it has a negative charge. It shows that the carbon is electron rich. There's a high electron density at the carbon. So when you have more alkyl group attached to the carbon, it will destabilize the carbon ion. Because the alkyl group is electron releasing group. So when you have more alkyl group attached in carbanion, the stability will decrease.